All right, so this is the quiz, or the quiz for Unit 1. So question 1 says, which of the following sequences are arithmetic? We have to select all that apply. So that means we do have to check every option. But remember, the idea here is that if we want to find things that are arithmetic, that means that they need to have the same common difference. So what we're going to do is check the common difference. So for part A, what we want to do is we want to go from 4 to 1. So I'm just going to rewrite these all the way down here. So 4 to 1 has a difference of -3. Then we go from 1 to -2. We're going back 3. Then to -5, down 3. And then to -8, down 3. Since these are all the same, we do want to pick A. We'll try part B next. B says we start at 9. Then we have to go to -10. So that's a difference of -19. We're going down 19. Then we have 11, but I think we can kind of see that this isn't going to work because now we're going to go up. So we went down the first time and went up the second time, so that can't work out. We go up 21, and we can just stop there. We don't need to pick anything else for part B, because once one of them doesn't work, you just don't pick it. Part C would be next. Here we have 1.0 to 1.2. If we subtract those, we're going up by 0.2. Then we go to 1.4, subtract those, that's 0.2. Then to 1.6, subtract those, we got 0.2. Since those are all the same, since they're all 0.2, we'll pick C. Last one we got to check is D. So we got to go from 1 to 1/2. If we subtract those, we'd be going down by 1/2. Now, I'm going to think about this one a little bit different. If I went down by 1/2 again, I should be at 0, but I'm at 1/3. So I don't really have to do all this work with the fractions. I know that that should be 0 if this was going to work out. It doesn't work out, so we can just stop right there. If you do want to check, we can do 1/3 minus a half. Sorry, 1/2 minus a third. To find out we're going down, well, yeah, I guess we're going down. So 1/3 minus 1/2, this would be 2/6 minus 3/6. We're going down by 1/6. If we go to 1/4, again, we have to get a common denominator, which in this case, we may as well just pick 12. This is going to be 3/12 and 4/12. So we ended up going down by 1/12. Again, these are not the same, so we do not want to pick D. So in this case, we'll pick 2 of them. And that's it for number 1. For number 2, write the first 4 terms of the sequence. So here we've got 5. 5 is where we're starting because we always start at n equals 1. So the first term is 5. That's kind of nice. And then down here, this gives us our instructions. That tells us how much we're going up or down by every time. So here it says take your number and subtract 5 every time. Well, 5 minus 5 is 0. 0 minus 5 is -5. And then -5 minus 5 is -10. That's the first 4 terms. So that's it. We're all done. We'll move on to number 3. So for number 3, find the sum of the arithmetic sequence. So in this case, I can see I've got the first term and I've got the last term, but I don't really know exactly how many terms in between I've got. So it might be a little bit of an issue. I can tell that I'm going down by 3 every time, though. So if I want, I can start by writing the equation. I'm going to do the explicit one. The recursive one probably wouldn't help because I would just have to keep going down by 3 every time. So a sub n equals a sub 1 plus n minus 1 times d. So again, I want to find out how many terms we actually have in this sequence. So I can figure that out because I do know a sub 1. A sub 1 right here is the beginning one, so we start at 4. I do know d. I'm going down by 3 every time, so that's good. I want to find n. I want to know how many terms are in this sequence, so I'm going to leave that as n. And one thing that I do know is I do know the last term. an is always the last term, and the last term over here is -56. So I could put -56 on that side. And now I have an equation where all that I'm missing is just one variable. I'm just missing n. So I just have to get the n by itself. So that doesn't seem too bad. Just like we would normally solve this, we'll do -4 both sides. So that'll be -60 equals n minus 1 times -3. We'll divide both sides by -3. So -60 divided by -3 is 20. On this side, I now have n minus 1. I don't really need to write the parentheses now. And then the opposite of -1 would be plus 1. So I know that 21 is equal to n. So now I know how many terms there are. Since I know how many terms there are, now I can use the sum formula. Because that's what we wanted to do initially. We wanted to find the sum. So our sum formula, that's the S sub n formula. So our S sub n is equal to a1 plus an divide by 2, and then multiply this by n, multiply by the number of terms we have. So we can do this because now we know all of the information. So we're trying to find S sub n, we're trying to find the sum. A1 is 4. An is negative 56. So I'll just write that as minus 56. We'll divide that all by 2. And then we need to multiply by 21 terms. All right, well, let's see. We got to simplify a little bit. So S sub n is equal to 4 minus 56 would be negative 52. 52 cards in a card deck, so cut that in half, we'd get 26. So we'll have 26 times 21. Oops. Big whoops. All right, now we have to do 26 times 21. So that'd be the same as 26 times 20. So 520 plus another 26. So that should be 546. All right, so I think I got the answer. But again, I kind of did a lot of this without the calculator. I kind of did some hand waving to try and figure out what these are. So if I'm not sure, I can go ahead and plop it in and find out if I actually feel like I got the right thing. So instead of actually plugging this formula in, remember we do have another formula we could use. We've got sigma. We can use sigma. We can say we want to start the first term. I think we wanted 21 terms. And we knew the formula. The formula was going to be start at 4, n minus 1 times negative 3. All right, so I got negative 546. All right, so it's a good thing I checked because something went awry. So what went wrong over here? This should have been a negative 26. That's okay. It's okay to miss them sometimes. You just want to go back and find your mistakes. Just fix your mistakes. Negative 26, negative 546. And I may as well steal that Desmos code. Oops. Where did my camera go? There we go. I may as well steal this. Just so it's on the screen. We want this part. Because Sigma's a good friend, so it's good to include Sigma. You're not that good of a friend. We don't need to take everything up. But that's what we get. So a couple of different ways to do it. Again, either way we chose to do it, we still needed to figure out how many terms we had. So we still had to kind of use this formula over on the left to figure out what n was in order to find out how many terms we actually had in our sequence. But that's what we've got. So kind of cool. 2 different ways to do it. You can do it however you want. If you really found out that there were 21 terms, you could really write out all of them if you had a lot of time. Good luck, because it's going to take a long time to actually add up all 21 of those terms. But that's number 3. Number 4 is very similar. So in the theater, we have 20 chairs in the first row. Each row has 4 more chairs than the previous row, and there are 15 rows. How many chairs are there in the theater? All right, so for this one, we know that there are 20 chairs in the first row. We don't know how many there are in the last row. So since we don't know how many there are in the last row, I feel like this is going to be a better one to use the sigma for than using the sum formula, because we do know how many rows we have. We have 15 rows. And we know how many are in the first row. We'll fill that in a little bit. I'll just get the general formula down. N minus 1. And we also know we have 4 more chairs than every other row. So we know that D is going to be 4. So when we plug this in, N equals 1 to 15. A1 is 20. n minus 1, and then d is going to be 4 in this case because we get 4 more chairs every time. So again, we're going to throw this one in. Let's see what we get. 20 and 4 and 15. So 15 rows. Start with 20 chairs in the first row. Each row goes up by 4. 720. There we go. I will grab that. That looks pretty good with sigma. I'm really happy that we got it with sigma. All right. Like that a little bit smaller and just put that right there. A little bit smaller still. All right, so we did with sigma. So again, if we really wanted to, we could do it by hand. We could do it without sigma if we wanted to. Again, we would kind of have to repeat what we did on the last one, where we would start with our original equation. So a sub n equals a sub 1 plus n minus 1 times d. Now the problem here is that we don't know a sub n this time, so we would leave that as the variable. We kind of know everything else. A sub 1, we're starting at 20. N plus 1, we actually know n. This time there's 15 rows, so n is going to be 15. And then d is 4, so we could put a 4 in. So, I mean, again, doesn't look too bad because we have all of this information. We can simplify everything kind of quickly. So we're going to get 20 for a sub 1 still. 15 minus 1 is 14. 14 times 4 should be 56. 20 plus 56 is 76. And then we have to use the sum formula again. So we have to again write S sub n equals, I'll do it all in green for right now. I did it in colors on the other one. A sub 1 plus a sub n over 2 times n. So S sub n is equal to, a sub 1 is the first one, that's going to be 20. A sub n is the last one, so we figured that out. That's going to be 76. Divide by 2. And n is 15, so times 15. All right, this one seems like it might be a little bit trickier, but if we add these, we get 96. So divide that by 2, we get 48. So I have to do 48 times 15. Let's see, quick tricks. We'll probably do 50. 50 times 15 is 750. And we have to lose 2 because we're only doing 48 instead of 50. 2 times 15 is 30. So S sub n is going to be 720. Hey, that's what I got with sigma, so that works out. Perfect. So again, you can kind of do it either way. Honestly, this one's probably set up a little bit better for sigma, whereas this one, number 3, that one might be a little bit better set up to do by hand. But again, your call. You can even choose to draw out the entire theater. Be prepared to write out 720 little seats as a little image, though, if you want to draw the entire picture out. But at least you know how many you'll have to draw. For number 5, write a matrix that represents a system of equations. So we're not solving anything. It just says write a matrix. So that means all we have to do is write it. So remember, we're going to take the coefficient for x, then the coefficient for y, which is -1, and then what we equal to. Over here on the bottom, we're going to take the coefficient for x, the coefficient for y, and then what we equal. And then we're going to remember to make it a matrix, right like that. And that's it. That's actually, we're done. It just says to write the matrix. That is the matrix that represents the system of equations. So kind of like when we did the quadratic formula with the a's, b's, and the c's, we only use the numbers. We don't put any letters in there. All right, number 6 says use a graph to solve x plus 3, absolute value of x plus 3, then -1 equals the quantity x plus 2 squared. Our graph is going to be scored. All right, well, the easier one, I think, for us, since we did the quadratics first, is to just do the x plus 2 quantity squared, because this is just a parabola, but moving it up 2. We kind of know that from our transforms from the last unit. So that's going to look like this and like this. And then we have x plus 3 and the absolute value minus 1. So I can use some of my transform skills again to say I'm going to start at 3. Oops. Start at -3 because I got to go backwards inside the absolute value, comma -1. So I'll go 3 and then down 1. My slope for this is going to be 1. So I'm going to count 1, 1, 1, 1, 1, 1. Right like that. And then on the other side, I'm going to complete the V because I know the absolute value is going to look like a V. All right, so I've got my graph. I need to solve it, but the solution is always where those two connect. So it's going to be this point right here. So my answer is going to be 0, 2, and right here at 1, 3. And so those are my answers. Again, if I want to double check them, I can plug them in to check. And since we're asked to make a graph, not a bad idea to put this into Desmos to see what the graphs look like. So I'm going to do that right now. So we'll get rid of sigma. Sorry, sigma. Absolute value of x plus 3 minus 1 is what we have on the left side. And that looks pretty good. We pass through 0, 2. That's nice. We pass through 1, 3. We pass through 1, 3, 2. So that's nice. The other side, we had x squared plus 2. Oops. There we go. Did I get that right? Let me just double check. X plus 2 squared. Uh-oh. I did the wrong thing again. Man, another mistake. So that would have been right. But let's be honest. Sometimes we make mistakes. Oops, that's just the review guide. All right, well, let's go ahead and erase it. That's okay. We're allowed to make mistakes. That was such a nice one, though. I felt like I drew that parabola really well. Oh, well. So that looked like that turned out pretty good. These are going to have to probably change. Because we don't go up 2. We're inside. We got to go not up 2, but we got to go to the left 2. So let's move to the left 2. Oh, okay. So we got a couple different spots. That's all right. 1, 2, 3. Here it. So it looks like now I'm going to connect down here. That's at the point -2, 0. And here, -1, 1. I definitely should have checked those by plugging them in. But let's see what the graph looks like. So we want to do x minus 2 quantity squared. Oh, x plus 2. There we go. All right, and again, it looks like we're at -1, 1. We're at -2, 0. -1, 1, -2, 0. Just double checking because I've already made a couple mistakes on this one. So I just want to make sure I got the right answer. All's well that ends well. So that's what we want to do for that one. So that's what we got. So that's what we do for number 6. You can see what my graph looks like. This part is a V and this part is a U. So my graph needs to have both a V and a U on it in order for it to be right. So when I'm talking about that the graph must be scored or the graph is going to be scored, I'm looking for these key points. I'm looking for the vertex for the V. I'm looking for the vertex for the U. Looking for the V shape if that's what's appropriate. Looking for the U shape if that's what's appropriate for the parabola. And then to solve it, that's going to be our 2 intersection points. Again, we saw on the other unit that we could have 2, 1, or 0 with most of these ones. So a V and a U could also have 2, 1, or 0 answers. All right, number 7, kind of same idea. 2 absolute value of x plus 1 is greater than or equal to 3x. So the first thing I want to point out is that right here, we have the or equal to sign. That means this is going to be a solid line. If that or equal to wasn't there, we'd have to do a dashed line. So let's do them. This side probably, again, the easier side because 3x is just going to be y equals mx plus b. So start at 0, 0 and slope of 3. 1, 2, 3. 1, 2, 3. Way up here. 1, 2, 3. 1, 2, 3. All right, and we'll make a line. Feel like I just want to use the regular line tool this time. Wow, that did not go as well. All right, so we got our line. Now we need to do the other part. So with the other part, we've got 2 absolute value of x plus 1. So again, with my transforms, I'm not moving left or right at all, but I'm going to go up 1. So I know this v is going to start here. And then it says 2x. So I have a slope of 2. 1, 2, 1. 1, 2, 1. And it's going to be a v, so 2, 1. 2, 1. So we'll make a v this way. We'll v down this way. And then we'll make a v this way. All right, so it looks like this only has one intersection. That's at 1, 3. And that's okay. Again, the v's and the lines, just like with the v's and the u's for the parabolas, 0 answers, 1 answer, 2 answers. All right, so that's where we hit, but we got a greater than sign. So it's not just this point. This point does work, but there's a lot of other points too. So we have to pick every point where our absolute value v is greater than the line. Well, I can see that here I'm higher than the black line, here I'm higher, here I'm higher, here I'm higher, here I'm higher, until we get to over here. And then at this point, the black line starts taking over. So it looks like we're actually going all the way until we get to 1. So it's not just 1, 3. That's the point where they cross. We're going to be higher from negative infinity all the way out to 1. All right, let's just double check. Again, I didn't do so great with the last one, so let's just double check. So 2 absolute value of x plus 1. Where'd you go? Oh, you're over here. All right. 2 absolute value of x plus 1. Let's get rid of this. So again, my v looks like it's pretty good. I like where my v's at. And then 3x. Now, I do want to check my point. I'm at 1, 3. Is that the point that we saw was important from before? Yep, that was the point that we saw that was important from before. But now I need to make sure that 1 is greater than the other one. So we got to check if it's greater than 3x. Now, this is really weird. Like, that looks like a very weird thing. We don't want to put that on there because that's not going to help us very much. That doesn't give us the picture we want. We instead want to make that a y. And over here, we want y to be greater than 3x. All right, and so we can see this double shaded section is going to go from negative infinity. This is still double shaded purple, greater than or equal to. Let's make that a solid line like in the problem. And it's going to be dark purple, dark purple, dark purple, until we get to 1. So once we get to 1, we can see that it's no longer going to be dark purple. Over here we just have white, we have blue, we have light purple. So this is that double shaded section. So we can shade that in. So if we want, I can change that to make it look a little bit nicer. And match. Because again, we want this to be greater than or equal to y. So if we were to flip it, y is less than or equal to 2x plus 1. So we would shade down. And then for our line, we would say y is greater than or equal to 3x. So here we would shade up. And again, we had this double shaded section. So in this whole double shaded section here, that would be what our answer should be. So we'll get rid of our important point. I mean, it is an important point because it did give us the x coordinate that we wanted. But this double shaded region goes from negative infinity all the way out to 1. There we go. So that's what we got. All right, let's check out number 8 then. So for number 8, solve the system of equations by hand. Answers without process will score 0 points. So that means we got to solve it either with substitution or elimination. The way that this is set up, it looks like it's set up pretty well for elimination, because I think if I see this, I've got a minus y and another minus y. So if I subtract these, if I multiply everything by -1, now I can just add them up. So 2x minus x is x. Negative y plus y is 0, so I don't need to write that. 7 minus 10 is -3, so I get x equals -3 right away. That's pretty nice. To find out what the y is, I'm going to take the -3 and plug it back in for the y in the original. So I had x minus y equals 10. So -3 minus y equals 10. Add 3 to both sides. Negative y equals 13. Divide both sides by -1 because I got to get y totally by itself. Y is equal to -13. Final step answer is always a coordinate pair, x first and then y. And there we go. If I want to double check it, best way to double check it is to see if this actually works out. So 2 times -3 minus -13, is that actually equal to 7? -6 plus 13, is that actually equal to 7? Yep, 7 actually is 7. So that point does work out. Again, you can double check your answer if you want with a graph. You can graphically solve it to double check. But to get points for this one, you gotta do it by hand. So that's number 8. For number 9, write the row reduced echelon form for the matrix. This is a straight calculator question, unless you really want to do the 25 operations by hand. But you can use either Desmos matrix calculator, or you can use your TI. Now the TI I think is a little bit easier, but if we want to do it in Desmos, we need to make a new matrix. Our matrix here, we got to count the rows and columns. We've got 3 rows and 4 columns. Remember, this is just for our visual sake. We can see that these are kind of the results of our 3D system. So let's put that in. We got to have 3 rows and 4 columns. Now the hard part, remembering all the numbers. 1, 3, 2, 1. 1, 0, -1, 4. -4, 3, 0. Thought that was a -12. It is. All right. That's matrix A. We got matrix A. And so what we need to do is we need to do the row reduced echelon form. So you have to find the right button for it, but luckily row reduced echelon form is abbreviated with RREF. So the abbreviation is literally the button that we pick. And in the TI calculator, it's the option that you choose. So we're going to do RREF of matrix A. And that's it. That's our result. So since that's what we got, I may as well just steal that right from the calculator screen, because that'll show exactly how we did it. We'll move this down a little bit, and that's our answer. So our answer is the row reduced echelon form. It's going to be this entire matrix right here. Now again, if I wanted to write it on my paper, 1, 0, 0, 0, 1, 0, 0, 0, 1. And that's always going to be the same because we want to do reduced row echelon form. So we want to get this identity matrix. And then our answers, our x is going to be 3, y is going to be 0, and then z is going to be -1. So that's what we got for row reduced echelon form. All right, last one we got then. Finally, we got number 10. Emery used the row operations on an augmented matrix representing a system of equations and obtained the results below. How many solutions does Emery's system of equations have? So if we were to write this as a system of equations, this one would say 1x plus no y's is equal to 4, or x is equal to 4. So that seems pretty good. So far, so good. Here we have 0 x's plus 0 y's equals -3, which would say 0 equals -3. Well, that's not true. So this one has no solutions because 0 can never be -3. So we can kind of see what that would be by writing it out. Again, you can look at the form of the matrix as well and see the double zeros in a row and know that if you get double zeros in a number for an answer, you get no solution. And that's all 10. So that should be about it. So that's everything we got with the first quiz.